Now that we have our tree diagram, we're going to move ahead to calculating how many times does he have 2 goals. So we're going to look at all those options. So we've got our first pathway is 2 goals and then no goal. He could have first goal, no goal, third goal, or he could score both his goals at the end. Okay, so the probability that he has 2 goals is going to be the probability of one of those pathways. So 0, I'll trace it with my color here, so I'll use red. So let's follow the first pathway here. So if he scores a goal, we're going to start off with 0.3, multiply again by 0.3, that's the second branch in the pathway, and then he's not going to score at the end, so 0.7. If you follow either of these, you will get the same amount of probabilities and therefore the same result when you multiply them. So 0.3 times 0.3 times 0.7 multiplied by the 3 pathways. We've got decimals, so we can give our answer in decimals according to 3 significant figures. So his probability of getting 2 goals is about 0.189 or about 20%. So the second part of the question is what if he has no goals? So we're looking at the probability of 0 goals. There's only one pathway for that. I'll highlight that in green. So no goal would be no goal, no goal, and no goal. So we'd multiply 0.7 times 0.7 times 0.7, which would give us about 34% or 0.343. Our last option here is at least 1. So the probability of at least 1 goal is going to be 1 take away the probability that he gets no goals. You could add up each pathway as well, but we already have this information about no goals, which is going to make it a little bit easier for us. So 1 minus 0.343, which is our answer from B, is going to leave us with 0.657. So about 66% of the time he gets at least 1 goal based on the probability and based on the tree diagram. Next example is about Smarties. And now what we're looking at is we're going to take something out. We're not going to put it back, which means that our probability is going to change after each round. So in the box of Smarties, we've got red and green Smarties. If the box contains 15 green and 18 red, and we're going to take 2 Smarties from the full box. Okay, so let's start up our tree diagram. So we're going to pick twice. On our first pick, we could get a red or a green. On our second pick, we could also get a red or a green. Same thing down here. So let's fill in our probabilities. So our first red Smartie, so we've got 18 red Smarties out of a total of 33 Smarties in the box, 15 plus 18. Green is going to be 15 out of 33. Okay. And now what's going to happen, so we've taken a Smartie out of the box and then eaten it. So our next probability for drawing a red Smartie, if we drew a red the first time around, is 17, because we've eaten a red Smartie, out of 32, because there's 1 less Smartie in the box. For green, our probability is 15, because we haven't eaten any green Smarties, out of 32, because there's 1 less in the box. Similarly, for the second branch, we've got 18 out of 32, because we haven't eaten a red Smartie, but there's 1 less in the box. And then for green, we've got 14 out of 32. Okay, we've eaten a green and there's 1 less in the box. So let's look at the first one. So the probability that at least 1 is red is going to be equal to 1 take away the probability that they're both green. Okay, so I'm going to start with 1, and the probability that they're both green, may as well highlight that in green. That pathway is if I pick green on the first try and a green on the second try. So I can use my product rule to find that probability. So I've got 15 over 33 times 14 over 32, which when I calculate that all out, I should get 141 out of 176 as my probability that at least one is red. My second option here is if red is picked on the first pick, given that at least one green is chosen. So now we're combining our conditional probability. So we want the probability that it's red on the first pick, given that green is greater than 1, that we get at least one green. Okay, so we're going to set up our equation. So we've got the probability that you get red on the first pick, and you have green greater than 1. So that would mean that you get a green on the second pick over the probability that you get at least one green. So we haven't found that one out yet. So let's start up here. So we've got the probability that we get a red on our first pick and that we get a green that's greater than 1 is going to be 18 over 33. That's red on the first pick. And we're going to multiply by 15 over 32, which is green on the second pick. Okay. Now, on the bottom, what we're going to do is we're going to write this as 1 minus the probability that they're both red. So that's a little bit easier to calculate algebraically than adding all those probabilities together, but you could do it. There aren't that many options. So your denominator is going to be 1, take away the probability that they're both red, which would be, if I go back to my tree diagram here, my red pathway is up here. So 18 over 33 times 17 over 32. So I'll put that into my equation. So what did I say? I would have 18 over 33 times 17 over 32. Going through all of that algebra actually simplifies quite nicely, and you should get a final answer of 9 out of 25, okay? Which you can convert into a decimal if you want to. Last example that we're going to look at is Toby is a star of the tennis club. And this is another example where the probability changes as you progress through the tree diagram. Okay, which is a different type of situation. The information that we're given is that when he gets his first serve in, the probability that he wins is 75%. When he uses his second serve, there's a 45% chance of him winning the point. He is successful at getting his first serve in on 3 out of 5 occasions and his second serve in on 3 out of 4. So we're looking for the probability that the next time it's Toby's turn, he wins the point. And given that he wins the point, what is the probability that he got his first serve in? So let's set up a tree diagram for the situation. So his first serve can either be in or out. And the probability that he gets it in the first time is 3 out of 5. That means that the probability that he gets it out is 2 out of 5. Now, if he gets his serve in, then you're going to figure out if he wins the point or loses the point. So win or lose. If he gets his first serve in, the probability that he wins is 0.75. If he gets his first serve in, the probability that he loses has to be 0.25 because those two branches have to add up to 1. Now, if his first serve is out, he's going to get a second serve. And that serve can either be in or out. His second serve is successful 3 out of 4 times, which means that it's unsuccessful 1 out of 4 times. If his serve goes in, then he can win or lose the point. So win or lose the point. If he gets his second serve in, there's a 45% chance of him winning, which means there's a 55% chance of him losing the point. So the probability that he wins is going to be the probability that he gets his first serve in and wins, plus the probability that his first serve is out and that he wins. Oops. So we can add those two together. So we're going to look at the pathways. So the first pathway that we're going to do is probability that he gets it in and wins. So that would be this pathway in blue right here. And then the second one is in red. So if he gets his serve out, second serve in, and then he wins here. Okay, so we've got a red pathway and a blue pathway that we're going to multiply together using our product rule. So this first one would be 3 over 5 times 0.75. Our second one has 3 pieces to multiply together, 2 over 5 times 3 over 4 times 0.45. Multiplying all those together is going to give us 117 over 200, or you can change that into a decimal. And this is our A. Now the second question is bringing back our conditional probability. So what we want to know is the probability that he gets his first serve in, given that he wins the point. So we can set up our equation like we did learned about in the conditional probability video. So the probability that you get your first serve in and win over the probability that you win the point. So looking at those two, the probability that you get your first serve in and win, we actually have that up above. That's our blue pathway. So 3 over 5 times 0.75. On the bottom, we have our probability that we win. We calculated that on the first question. Okay. Multiplying those all out should give you 90 over 117, or you could change that into a decimal. So the first two examples are tree diagrams without replacement. The probability stays the same as you progress. The second two are probability with replacement, or where the probability changes from step to step.